out the equations in factored form. So on the test, when I give you a test, which is not next week but the week after, remember we talked about that, it's going to be before Easter. It's going to be on chapter 4 and polynomials. Okay? I will give you a graphing question where I ask for an equation. If you're like, I wonder if she's going to do that, she will. It's an outcome. I'm going to hit it at least once, possibly twice, right? Like that's what's going to happen. Okay? So when I give you a graph and I ask for the equation of a polynomial and you try and put it into this freaking form, and I get so sad because I'll live at this moment and I'll rewind the tape from yesterday at 15 seconds. I explained this, and now at 35 I'm explaining it again. When you're given a polynomial graph, you cannot put it into this form directly. You have to do the factored form with an A, solve for your A every time. So these should be easy questions. I see this, I do factored form. Solve for A, poof, poof, poof. I get an answer. Like I don't have to guess what I need to do. That's what you have to do. Okay? So for this one, I have y equals A, x plus 1, but there's a tangent there. So what is it? Squared. Then x minus 2, but there's a point of inflection there. So what is it? Cubed. And then I have x minus 4, and it goes straight through it. So I could put a 1, but there's no point. Right? Then I told you there will always be a bolded point. Always. If it's not a bolded point, they'll have it in like the statement at the top. They'll talk about the point. Okay? But they'll give you a point. So this one here is at 0 and negative 4. My goodness. You know, you guys can take you out of your house, but can you? I got nothing. All right. So we have negative 4 equals A, 0 plus 1 squared, 0 minus 2 cubed, 0 minus 4. Negative 4 equals A. This is going to be a 1 times a negative 8 times a negative 4, which means I divide by 32. Negative 4 divided by 32 is negative 1 over 8. And that's my A. And people will tell me, poof, you have the equation. No, you have an A. I have an equation that I didn't even ask for. That's what you have. However, you have to find that equation first, correct? Always, always, always. It should be a no-brainer. I see a graph, ask for equation, do factored form with an A in front. Solve for A every time. So I'm going to get y equals negative 1/8 A plus 1, not A, where the heck did I get that? X plus 1 squared, x minus 2 cubed, x minus 4. Cool. I asked for it in the form of this. They won't, I could say they will never, but they don't. But they could, I guess. So this is the form I have on top. Now, first off, this is a cubic, which I won't ask you for because I have to stop. Sorry, this is like a degree 6, which I won't ask you for because I have stopped degree 5 as the curriculum, right? I can go from nothing to degree 5. But I'm trying to prove a point that it doesn't matter what I hand you. You should be able to do any of them up to degree whatever, right? Now, if they ask for any of these, you would have to actually expand that. And that would be terrible. Okay? So the majority of the time, they do not ask for the in-between letters. Because that's just testing your polynomial skills, which are from grade 10. Like, expanding polynomials is a grade 10 outcome. That's why you learn it in grade 10 is for grade 12 and grade 11. Okay? But being able to expand that is really a grade 10 outcome. So if they ask for B to F, they're asking you to expand. They're kind of asking you for grade 10 outcomes. So they don't really ask for that. Could they? Sure. Okay? But if they did, you'd have to expand it, collect like terms, put it in order, and then you'd state it. If they ask for A instead, you do not have to expand the whole thing. You just need to find the coefficient in front of the x6. So how do I deal with that? So if they ask me for the leading coefficient, I always do this. I go y equals negative 1/8, and I rewrite every single one of these out fully. So x plus 1, x plus 1, x minus 2, x minus 2, x minus 2, x minus 4. Then all I have to do is multiply all the x's and the coefficient. So if I go negative 1/8 times x times x times x times x times x times x, I actually get negative 1/8 x to the 6th. And I have my 8. So all I have to do is literally multiply this by this, by this, by this, by this. So your A will stay the same unless one of your x-intercepts is not an integer. If your x-intercept is like a half, say I had x equals a half, I would have to work that back by multiplying by 2, and then subtracting 1. And then one of my factors would actually have a 2 in front of it instead of just a 1, right? So I have to multiply by 2, not just x times 1x times 1x times 1x. I'd have to go like 1x times 1x times 1x times 2x times 1x times 1. So if you actually have a number in front of your x, you have to multiply by it. But that only happens if your x-intercept is not an integer, is a fraction, like a third or a half or 2/3. Do you know what I mean? Then you'll end up with a number in front of that x that you have to multiply by. Does that make sense? All right. Now, the other thing they ask for, and then you don't have to do the whole expansion, is the constant at the back. When you hear constant and no brackets, remember it has to be a constant with no brackets. Do you see that? There's no brackets in here. Some people will want to try and write the constant back here. No, this is a totally different form. This one doesn't have a constant. If I wanted to get the constant, I could FOIL the whole thing out and get the constant, which would take forever, which some of you did, I saw in your hand. Or the constant is just the what? The y-intercept. This graph, I even gave it to you. So g equals -4. Because that's what my y-intercept is. Right? I didn't even have to do any math. If I wanted to show it algebraically, I could take this form, though, and plug 0 in for what to get the y-intercept? What equals 0 for the y-intercept? X. So I could go y equals -1/8, 0 plus 1 squared, 0 minus 2 cubed, 0 minus 4. And when I multiply that all out, I get -4. So g is -4. I could do it that way too, if it wasn't just on my graph. So to find the leading coefficient and the constant, do I have to FOIL out the whole thing? No. Can I ever get it directly into this form, guys? Can I ever just go put it into this? No, never. So if I'm asking you to come up with an equation of a graph, it doesn't matter if it's in that form. I have to do factors with an a in front, solve for a, get my information, and then they often ask you for the leading coefficient or the constant or both. If they ask you for any in between, you have to FOIL the whole thing, and you pray that it's a quadratic or a cubic at max, because that is a little less work, right? So, what is this graph? It's a degree 5. There's a hint. It's also a degree 5 because there's how many here? And how many here? 3. So 2 and 3 is at minimum 5, right? Remember your degree, the maximum number of x-intercepts you can have is equal to the degree. So if the degree is 5, I can have it max 5. So if I know I have 5 there, I know this is at least degree 5. Okay? So when I go to fill this one in, I'm going to go y equals a, x minus 2 what? Squared, because it's a tangent, and x minus 4 cubed, because it's an inflection. Now remember, inflections could be 5, 7, 9, 11, right? They can be odds, and tangents can be evens, 2, 4, 6, 8. However, this is an x5. So 2 and 3 makes 5, correct? So I can't make this be a 4. So if they tell you it's an x5, you're stuck at a 2 and a 3. They don't have to tell you lowest or anything like that, right? Because that gets you 5. You can't go any higher than that. If I made this be a 4, minimum this one can be as a 3. That's 7. We're too big. Okay? Now, I bolded 3 and -1 as a coordinate. So we get -1 equals a 3 minus 2 squared, 3 minus 4 cubed. -1 equals a 1 squared, -1 cubed. -1 equals a times -1 technically. What's my a? It's just 1. And I go y equals 1, x minus 2 squared, x minus 4 cubed. Now I'm going to ask for the a of this equation and the f of this equation. If I ask for anything else, you have to expand the whole thing, right? I have seen them ask for something else before, but I think it was a cubic. Like, they don't make it be up to degree 5, because that's insane. Like, it's a lot more to expand if they ask for one of the letters in between B, C, D, E. All right. So I rewrite it as y equals 1, x minus 2, x minus 2, x minus 4, x minus 4, x minus 4. Now the a I find in factored form is the same as the a in standard form if all of my x-intercepts are integers, right? If all my x-intercepts are integers, I'm going to multiply my a by 1x times 1x times 1x times 1x times 1x, and whatever my a is, it will stay. So it'll be 1x to the 5. So my a equals 1. My a will not stay the same in standard form if I have fraction, not integers, right? Roots. Because I'll get numbers in front. I could get numbers in front. Now what is my constant? So I can't just pull the y-intercept off of here, correct? But it does look like it should be negative somewhere. Like, it looks like it's leading down here. So if I'm getting a positive, I should be a little bit sus, one might say. Yeah, I use sus. Luke is dying. All right. You okay?
Where'd you do that?
Where do you think?
I'm guessing in the classroom for you to.
I have a kid in grade 3 and 6.
Yes.
They play Among Us.
Still?
Grade 3? You want to cut? Like, when Among Us first came out, my grade 12s played it. So you don't say still to a 3 and a 6. They're just babies. Like 9. All right. I'm glad you guys coped with that. All right, so we need the y-intercept to get the constant, which means x equals 0. I literally just say sus and then stand back and watch because it's kind of comical. I just wait to see your face. It brings joy to my heart. Okay. So I'll do it probably in another 3 weeks from now just to see what's going to happen again. Maybe 4. Maybe June. You won't expect it. So we have y equals 1, 0 minus 2 squared, 0 minus 4 cubed. Do I need to write this 1 for the a if it's a 1? Nah, I'm just being cool, so I wrote it. 1, negative 2 squared is 4, negative 4 cubed is negative 64, and then 128, and then 256? Negative? Just a little big, just a little. So I would say f equals negative 256. Does this make a little more sense as to what I'm asking? So as you've seen in the questions that I released to you, which are all old practice diploma style, they rarely ask for it in factored form. They often ask for it in the equation. They ask for the a or they ask for the d, you know, the constant. And then you all try to put it in that equation, which doesn't work. Or you foil the whole thing, which works, but wow, it's just, there's a good chance of making an oopsie. Or you're using like a bristle board page to do it. So there's those options. Okay? All right. We are going to the notes, where we left off in the notes. A unit circle. Whoop, 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 whoop. Take out your little spinner. Spinny Spinnerton. Okay, so this is what we're going to do here. It says state the coordinates of the intersection. Now what I want you to write at the top of your little spinny unit circle is I want you to write cos theta, sine theta. It's Calgary Stampede. Just write it down. Don't question me, okay? So in your coordinate, you have cos theta, sine theta. You were taught this last year, and you're acting like you were not, but I promise you, you were. Yes?
I know that was.
Look, I do. Don't throw this out. We're supposed to keep them. It's not filled in. Be neat. I actually said, be really neat when you fill this in, and then you toss it. We'll see. Might be a possibility. Might be a selling feature. Might really suck to be Noah when he can't use his dinner. Maybe that'll be his punishment. Yeah? All right. Oh boy, now I don't have. It's okay. I will make myself. Oh, I don't even have an arrow. All right, we're gonna keep talking. So, cos theta, sine theta. Oh, cos theta, sine theta. You got it? Everyone have that on the top of their unit circle? Yeah. Now the way we remember the order is Calgary Stampede. Okay? Calgary Stampede. You can have your own other way if you'd like to memorize it, like Crystal sucks. I wouldn't go with that one, but if it works for you, that's fine. I cut my own self down, it's fine. Or you could use Crystal Snappy, or like Crystal Saucy, or like Crystal Slays. No. Or we could use Crystal, I'm trying to think of like a really good like Supreme Ultimate Being, you know, like maybe like that. Yeah, that's what it is. Crystal Supreme, Crystal Superior. Yeah, that's kind of like, yeah, like you know they call them Mother Superior and like, yeah, Crystal Superior. I like that. Yes, Crystal Superior. Kick out Calgary Stampede is being replaced with Crystal Superior.
Just keep asking me. It's fine.
Yeah. Okay, we're ready. I'll fill mine in a second. Now, going back to the question. This one says, state the coordinates of the intersection of the terminal arm and the unit circle on the following rotational angles. So we go to pi over 2. Pi over 2. Halt. What's that pi over 2? Remember, the outside is the coordinates. The inside is the angles. What is the coordinate at pi over 2? 0 and 1, because it has a radius of 1, right? I see where you were going. I see where you were going. You were, yes. Yeah. What other point, what other angle is there too? What other angle has that coordinate? I was trying to set you up here. What did you say? 90 degrees. So P of 90 degrees also has it. Or we could do coterminals of it, right? We could do negative 270. Negative 270 goes like this. This one's not working as well as my other one. You got my good one. Negative 270 would land on the same thing, right? Like if I said P of negative 270, I would get the same answer. Because those are all coterminals, correct? I could do negative 3 pi over 2. Because that is the same as negative 270. All of these would get 0, 1. Yes? Okay, negative 3 pi. Let's go. Negative pi, negative 2 pi, negative another pi, gets me to here, which is where? What point? Yeah, it's at 180, which is the coordinate is negative 1, 0. Now, what you could do is just find the coterminals of it, correct? Till it lands on your unit circle. So what I could do is I could go, okay, what's negative 3 pi plus 2 pi? Negative pi. Cool. Is that still on my unit circle in my principal angle between 0 and 2 pi? Nope. So what could I do again? Add 2 pi again, which gets me pi. So actually, this is the same as P of pi, right? It's just a coterminal of it. Could I not just do the coterminals till I get myself on the principal angle unit circle? Absolutely. Because they land on the same thing. Next one is 7 pi over 2. That is not on my unit circle. But I could find its coterminal that would land on it. What do I have to do? Is it too big or too small? If it was too small, it'd be negative. So it's too big. So I can go 7 pi over 2 minus 2 pi. What does that get me? 3 pi over 2. Remember, how can we put these in if we want to put them in our calculator? Without pi. Is 3 pi over 2 on my unit circle? Yep. Same as 270. So I'm going to start here. And we'll go 270. What's my coordinate there? Hmm? 0 and -1. $720. Too big? Too small? Your circle goes from 0 to 360. So is it too big or too small?
Way too big.
Way too big. So we are going to take 720, and we're not going to subtract 2 pi. What are we going to subtract? 360, because it's in degrees. And that gets us 360 degrees. So I want the coordinate. This is the same as p of 360, because I'm finding all the coterminals. So we learn coterminals first. So I go to 360. Here it is. What's the coordinate of 360? 1, 0. Now, principal angle is the smallest positive angle between 0 and 360 and 0 and 2 pi. And I was making you find it because it's a lot easier to pull the angle off the unit circle if you can look for the actual angle that's on here. A lot of people find it hard if you have to visualize, like rotating a whole bunch of times, right? But if I wanted to with 720, I could. So this would be 360 going around in a circle. And then I would go, okay, another 90, another 360. Oh, 720 lands me on the same spot as 360. Like I could literally rotate it. Yeah. 1.
Oh, I think I got it.
You asked for only a second.
Yeah, we're good.
Did you get it?
I got it.
Impressive. I didn't know you were going with the phone. So that would have worked a lot better than how fast you were writing. All right. So, using the above information, determine the coordinates on the unit circle for each of the following. So I want the coordinate at 60, the coordinate at 7 pi over 6, 240, 120. Those are all principals. So this should be fast. Go to your unit circle, pull off the coordinate. This one is 60. 60 is at what and what? One half and square root 3 over 2. 7 pi over 6 lands in quadrant 3, so they're both going to be negative. And what are they going to be? Negative square root 3 over 2 and negative 1 half. Don't all answer at once. 240. 240 is going to be at what? Negative 1 half and negative
Root 3 over 2.
root 3 over 2. 120 is going to be negative
1 half.
yeah, and
Root 3 over 2.
3 over 2. Are these ones principal angles? No. So this one's too small, so I'm going to have to add 2 pi till it falls on here, right? This one's too big, so I'm going to have to subtract 2 pi till it falls on there. This one is too small, so I can add 2 pi till it falls on. We've already done this one, just in case you were wondering it's above. Try those 3 out. So this one I'm going to have negative 5 pi over 3 plus 2 pi, and it gets me pi over 3. And then I'm like, on the unit circle. Amazing. And then I write down the answer. So this, it's cool because it's on the unit circle. So P over P of pi over, these are the same thing, right? Every coterminal that's arm lands on that spot gives that same coordinate. True statement? Yes. So what do we get here?
1 over 2.
There you go.
Root 3 over 2.
Yep. Now this one's too big, so I do 19 pi over 6. Subtract 2 pi, which gets me, don't all answer at once, 7 pi over 6. And it is on the unit circle. Crowd goes wild. Yeah. Just kidding. 7 pi over 6. And what is the coordinate at 7 pi over 6? and negative. Boom. Oh, why did I just put a square bracket? I'm so used to doing domain and range. Okay, negative 3 pi. We've done it above and do it again. Negative 3 pi plus 2 pi is negative pi, plus 2 more pi is pi. Which is negative 1, 0. Whoa! Now they're giving us the point, and they want the angle. Now the catch is, if I give you an angle, paying attention, if I give you an angle, there is only, I don't know why I'm doing that, I need, hello, attention, I need like those little, like the airplane lights. Up here. Okay, so I'm going to keep doing this, I don't know why I'm doing it, but I'm going to. So, if I give you an angle, you have 1 point, that will work with it. True statement. Question mark. Yes. But, if I give you a point, there is actually an infinitesimal amount of answers you could give me. I really wanted to use the word infinitesimal. Infinitesimal number of answers you could give me. Is that not true? Like, for example, I should say, for example, negative 1, 0 is right here. Yes? That is pi. That is negative pi. That is negative 3 pi. That is 3 pi. That is 180 degrees. That is, like there's so many answers. So little time. Right? So when I ask an angle, one answer can come out of it. When I ask for an angle from an answer, you give me coterminals for days. Right? So that's why we will restrict you. I want from 0 to 2 pi. So those of you giving me the answer 180 degrees, I am saddened by the fact that you gave me degrees when I gave you a radian restricted domain. Okay? If your restricted domain is in radians, you cannot give it, well, you can. You can give an answer in degrees. You will be wrong. But sure, whatever. So if your restricted domain is in radians, your answer has to be in radians. So what is the only answer of all of these that fits between 0 and 2 pi? Pi. Very good. Also note to self, 2 pi does not have an equal sign. Do you see that? 2 pi does not have an equal sign. So 0 can be an answer, but 2 pi cannot. So if it landed here, I could give the answer 0. Like if I gave you 1, 0. I could give you the answer 0, beta equals 0. I can give you the answer 2 pi, and then I'd have to say, but I can't actually, because it's not equal to. Okay? Just watch yourself, equal to signs and then not equal to signs. So I want you to give me all the angles between 0 and 2 pi for B, C, and D. Go. I want to draw your attention to negative 1 over root 2, which people can't find on their unit circle. Negative 1 over root 2 is the non-rationalized version of root 2 over 2. Because if I want the radical to go away, we learned this last year, we multiply this by root 2, and then this by root 2. So I would get negative 1 root 2, or just negative root 2. And what's root 2 times root 2? 2, because root 2 times root 2 is actually root 4, which is 2. You learned last year that if you multiply two radicals that are the exact same together, the radical sign goes away. Because root 2 times root 2 is root 4, and the square root of 4 is 2. So if I multiplied root 7 times root 7, I would get root 49, which is 7. Root smiley face, I would get smiley face, right? Like it doesn't matter what's underneath. As long as they're the same, you get out what you put in. So, root 3 over 2 plus a half. This is in quadrant what? Try it. 1. Why is it in 1? Positive, positive. So, positive, positive. Oh, you were doing this one?
Yeah.
Yeah, I feel you. I get it. I got it. I'm all over it. That is quadrant 2. True statement. Okay, root 3 over 2 and a half is pi over
6.
6. This one is in quadrant 2. It would be the exact same as negative root 2 over 2 and root 2 over 2, which is a 45. The 45 and root 2 is 135, which is 3 pi over 4. And then this one is in quadrant 3 because they're both negative. Negative, negative is in quadrant 3. Negative a half and root 3 over 2 is a 60. So it's going to be 5 pi over 3. Yes? Oh, it's a 30. It's a 60. 4 pi over 3. This is in quadrant 4. Come on, Lepp. Grab a mitt. Get in the game. Of course it's 4 pi over 3. 1 over the denominator. It's a 60 degrees, so it's over 3. What was I thinking? I wasn't thinking. Shame on all my houses. I have one, so I'll just shame it. All right. It's a curse on all your houses for like Shakespeare. Isn't it a curse on all your houses? On all the houses? A curse on the house? Google it. Hannah, that's on you. You'll find out which Shakespeare it is. We are here. I don't remember much about Shakespeare, and by nothing mean nothing. Light on yonder window breaks is from one of them too. Because I thought a light yonder was breaking, but that's no. Romeo and Juliet? A plague on all your houses. Who won? Well, plague, you died. Well, curse, you could die, but a plague, you are dying. What was the plague? Plague was the bubonic plague, and if you got it, you didn't make it. And it came from rats. Sure. But it was not a good. You didn't have good chances. I would choose to personally not chance with the plague. You know? Still recording. No reason. Okay, so we're gonna. This doesn't exist. Me making it blue is making it worse. But just pretend it's not there. Okay? This random blue squiggle. I have an extra bracket for some unknown reason. Now, this one here says determine the missing y coordinate for the point on the unit circle. Now remember, if it said in polynomials is a factor, what did you immediately do? You underlined it and said, it says in polynomials, oh my goodness, is a factor. You underline it and you say what? The remainder is 0. Oh my Lanta, you should write that down somewhere and then look at it every day until the test. If it says is a factor, we underline that and we say the remainder is 0. Promise you, I said that at least 4 times, and no, you can roll back the tapes. In the podcast, it is stated and underlined. It's also in your handed, so that scares me for these people who did that question. If it says is a factor, that means the remainder is 0. Okay? In this unit, if it says on the unit circle, we use this equation.
It's not negative x squared. It's just
X squared plus y squared equals 1. Yeah. This is a dash, but we'll just go with that. I don't want to get rid of stuff, I just make it blue. So I'm fixing all the problems. Okay, now the reason why it's x squared plus y squared equals 1 is the unit circle formula for any circle, is not plus. For every circle, the formula is x minus h squared plus y minus k squared equals r squared. That is the formula. H and k are the center of the circle. What is the center of the unit circle at?
0,
0, 0. Remember, it's this little tiny thing that's in 1, 1, 1 block. So the center of the unit circle is 0, 0. So I'm going to put a 0 in for my h and a 0 in for my k. What's the radius of the unit circle? 1. So what do I do when I fill that in like that? I get this. X squared plus y squared equals 1. So if it says on the unit circle, you have to think x squared plus y squared equals 1. Okay? Now it's saying point A is on the unit circle and it's in quadrant 2. So if it's on the unit circle, this is my x, this is my y, I can plug it into that formula. If I remember the formula, easy question. Forget the formula exists, impossible question. There's no in between. So the formula is x squared plus y squared equals 1. So I'm going to get negative 4 over 5 squared plus, I don't know what y is, equals 1. Then we get 16 over 25, not sure why I'm putting in brackets currently, but I am, plus y squared equals 1. What do I have to move next? 16 over 25 by doing what to it? Subtracting it. So I will get 25 over 25 minus 16 over 25, which is, typing it in, oh y'all, because you need to be able to do this, 1 minus 16 over 25 in a fraction. 9 over 25. Now, craziness is going to ensue. I am going to take the square root with my hand, like this. When I make that motion with my hand, what should I remember? Plus or minus. This one's cool because both of them are perfect squares. So I get plus or minus. The square root of 9 is 3. The square root of 25 is 5. Now I get two answers. If they don't tell me what quadrant it's in, I get two answers. I would get two coordinates. I'd get one at negative 4/5 and 3/5. And then I would get one at negative 4/5 and negative 3/5. However, it did give me a quadrant. It gave me quadrant 2. Which of those points would fit in quadrant 2? The first one. Negative x, positive y, because quadrant 2 is right here. Right? This one fits in quadrant 3, which I'm not allowed to have. So this is my answer. You try B quick. So I told you before, it's not often the grade 12 that gets you in trouble. It's the grade 10 and 11 because you forget your little rules. So this one, we would have x squared plus y squared equals 1. So I would get 9 over 100. This one's still okay. It's this one where we're going to, this one. Anyways, 9 over 100 plus y squared equals 1. Then I subtract the 9 over 100 from both sides. And then I get y squared equals 91 over 100. And then people take the square root. And when you take the square root, you get plus or minus. Yes? Everyone's following me to this point. And then this is where your grade 10 math comes in and you guys have to be the right answer. But you will after this moment because we are going to remind you. In grade 10, you are taught that you can split up radicals. You are taught that if they give you square root 3 over 5, you could write it as square root 3 over square root 5. Now, why would you in that case? You wouldn't. But why is that a rule? That's a rule because when you are given a fraction and one of the numbers is a perfect square, you're going to split it because you can deal with one of them and make it nicer, but you can't. Like the 91 ain't going anywhere, right? Root 91 is root 91. I can't even reduce it. Okay? It's a prime number. But root 100 I can reduce to 10. Correct? So that's why in grade 10 you're taught you can split a radical up. So we're left with y equals plus or minus root 91 over root 100, which equals plus or minus root 91 over 10. So my two coordinates would be 3 over 10, comma, root 91 over 10, or 3 over 10, comma, negative root 91 over 10. If I don't have a split as to where it would be, I'd get both answers. But this one says quadrant 4. Which of those two is in quadrant 4? First or second? Second. So I do this, and I go like this. You guys, I want you to do this. So I want this. Is each point on the unit circle? When I see that, when I see is a factor, I think what? I'm going to do this like every single time, just throw it out. Polynomials. Is a factor. The remainder is 0. Is a factor. Don't all answer once. I know Taisei knows it, but I think the rest of you don't. Is a factor. Cohen. Remainder is 0. Tai. Tai. Is a factor. Both of you. You're Tai. That's you together. You're one human.
You ready?
Yeah.
Rip, come on.
3, 2, 1, go.
Remainder is 0.
Thank you. That's beautiful. If it says on the unit circle, if I call you tie ball or tie A or tie archer, then that's separate. But if I call you tie, that is a combo. Yeah, together. All right. On the unit circle, x squared plus y squared equals 1. You have to check that, right? So they want to know if it's on the unit circle. So all we're going to do is plug this in for x, plug this in for y, see if I get 1. Plug this in for x, plug this in for y, see if I get 1. Go. All right. 0.65 squared plus negative 0.76 squared equals 1. And then people will tell me, yes, 1 equals 1. But is that true? What does the left-hand side equal? Pretty close or 1? What is it?
0.0001.
Where does this unit circle radius max out at? 1. Is that 1? No. No one on there can see it, but that's why you come to class and not just watch podcasts. But on my unit circle in front of my face here, it's like out here. It's like just like, oh, here's the line, and it's like out here. And it's like, not today, sir. Not on the unit circle. Yes. Make another wish. 11:11. This class, we get to make 2 wishes. Couldn't get better. 10:10, 11:11. Come back at lunch. 12. No, that's after. Yeah. All right. No. Not on the unit circle. Because this is not a true statement. That's not equal. Oh my gosh. Every time. Fall for it. This one
B's on the unit circle.
is. There's those of you who are like, yeah, it's in front of my face. No, that's not good enough. You have to prove that 1 equals 1. Fun fact, you're done 2 of 4 lessons in the chapter. Oh, on Monday, student teacher comes too, just a reminder. Okay. Page 186.